Hello students, welcome to EPG Pathshala. I am Dr. Anjali Sharma from University of Delhi. Today we are going to discuss about the module Materials for Coal Conversion Technology from paper Energy Related Materials. So students, let us see what we are going to learn in this module. From this module, we may get to know about the following things. First, why catalysts are used in coal conversion and what materials are used in coal gasification and coal liquefaction. The rising worldwide population and increasing energy hunger of emerging and developing economies such as China and India is making the demand for energy increase at a large rate. Traditional fuel sources such as coal, oil cause emissions of greenhouse gases, which is a major concern for climate change. The ultimate goal is to use renewable energy sources such as solar or wind power where the emission of greenhouse gases is zero, but renewable energy still needs a few decades of development and appropriate solution for the traditional period of translation. Since the reserves and resources of coal are considerably larger than those of crude oil and natural gas, with a more balanced geographical distribution means that there be a renaissance of coal if it is not already happening, especially in countries like China and India that have particularly large coal reserves. Catalysts are commonly used in chemical and petroleum industries to increase the rate of reactions, sometimes making certain previously unachievable products possible. Acids through donated protons like H plus are common reaction catalysts, especially in organic chemistry. Catalysts take part in the reaction but are not at all consumed. Many metals like platinum, iron, or nickel also have catalytic activity. Metal catalysts are used in automobile catalytic converters to reform carbon monoxide and nitric oxide pollutants. For example, catalysts can be used to enhance the reaction involved in gasification. Many gasifiers must work at higher temperatures so that the gasification reaction will proceed at reasonable rates. Unfortunately, high temperatures can sometimes be useful for specific gasifier materials, extra energy input, and cause efficiency losses if heat cannot be reclaimed. One particular problem area is the temperature gap between gasifier and syngas cleanup, which can be several hundred degrees Celsius. Having to drop the syngas temperature so drastically introduces efficiency losses. Approaches to combat this include research into warm gas cleanup and the use of catalysts to lower gasifier operating temperatures. The main objective of these studies have to be improve the production of water gas, producer gas or hydrogen gas as source for ammonia production. Most of these works were carried out at low pressure and have little quality value in assessing the catalytic effect in coal gasification for methane production. Catalytic gasification of carbon has attracted much attention recently. A majority of the elements in the periodic group have been tested as potential gasification catalysts and a number of leading candidates have been identified. Catalysts that are active at low temperature would favor the process of direct gasification for methane production, since low temperature and high pressure favors the formation of methane. Catalytic effects on gasification of carbon materials have been studied for several decades. The mechanism of catalytic gasification are still not completely understood and are not the same for all the catalyst system and reactions. In general, reactivity of catalyzed carbon is at least one order of magnitude higher than those of the uncatalyzed carbons. A majority of elements in the periodic table have been tested as potential gasification catalysts. The main objective of these studies have been to improve the process of production of water gas or producer gas. Outside of the work at Exxon, these work have little qualitative value in assessing the catalytic effects on coker gasification for production of methane from steam. Now let us see why catalyst is required. A catalyst would be that substance which would give you an option of a shortcut bypassing that lengthy snaking route. By giving you a new alternative route, you can proceed going on towards where saving energy and time. We often need catalysts to perform reactions at appreciable speeds. A catalyst is a substance that increases the rate of reaction without being used up itself. Coal gasification has been given particular emphasis because of the extensively availability of coal as a natural resource in this country, and several large-scale process development programs are currently being conducted under government and industrial support. The major thrust of these programs has been to utilize modern technologies to develop processes with significantly improved efficiencies as compared with the classical European gasification systems. Data available from the different programs currently at various stages of development already indicate that the objectives of improved efficiency and performance will be achieved in near futures. This evidence also indicates, however, that practical limitations still exist to efficiency levels obtainable solely through manipulation of process configurations and the use of modern gas solid contacting system, and that these limitations are due to the chemistry inherent to coal gasification in the absence of majority catalytic influences. The fact that these limitations are not theoretical or thermodynamic in nature, but instead result from relative and absolute chemical kinetic characteristics that has created considerable result in the use of catalysts in gasification systems as a basis for further significant improvement in process efficiencies. Now, let us see what is catalyst in coal gasification and coal liquefaction. So, to begin with, we'll see what is catalyst in coal gasification. Catalyst can be used to enhance the reactions involved in gasification. Many gasifiers must operate at high temperatures so that the gasification reactions will proceed at reasonable rates. Unfortunately, high temperature can sometimes require special gasifier materials, extra energy input, and cause efficiency losses in heat cannot be reclaimed. One particular problem area is the temperature gap between gasifier and sign gas cleanup, which can be several hundred degrees Celsius. Having to drop the sign gas temperature so drastically introduces efficiency losses. Approaches to combat this include research into warm gas cleanup and the use of catalysts to lower gasifier operating temperature. Now, catalytic coal gasification can provide a competitive source of gas for domestic as well as industrial uses consequently. Catalytic coal gasification has been the subject of numerous studies. However, the mechanism of CCG, that is catalytic coal gasification with catalysts like potassium carbonate, is not clear, so no simple mechanism is known by which a solid can catalyze the rate of reaction of another solid. Taylor and Neville reviewed the older literature on CCG and presented some raw data. Similarly, Johnson and Cusumano reviewed some of the modern literature on CCG. The thermodynamics and kinetics of gasification reactions were reviewed by von Fredersdorf and Elliott. Haynes et al. Screened various materials as catalysts for coal gasification. They informed that alkali carbonates like K2CO3 are very effective catalysts for coal gasification. Wilson et al. Examined the effect of mixing nickel with alkali carbonates on the rate of gasification. They too found that alkali carbonates enhance the rate of gasification. Wilson et al. Have also found that nickel that was added to the char enhanced predominantly the methanation reaction of the gasification products like CO and H2. Chauhan et al. Examined the effect of incorporation of calcium and sodium on the rate of coal gasification. They also examined the effect of particle size and the impregnation period of the coal on its rate of gasification. They found that small particles are consumed at faster rate than larger particles, and that the rate of gasification levels of after a given fraction of coal has been gasified. Wilkes et al. Compared the time needed to gasify 90% of one char and two coals using various catalysts. They observed that impregnation of the coal with the catalyst is much more effective than adding the catalyst to the coal. The methane yield was the same whether a catalyst was added to the coal or not. Addition of 30% of carbon monoxide to steam suppressed the rate of gasification. A major study of various gasification catalysts and the rate of gasification has been conducted by Exxon Research and Engineering. Nahas and Gallagher published data on the rate of CCG using K2CO3, and Weatherwick and Ekman published a model for the rate of CCG. On the other hand, Tomita et al. Confirmed that all common minerals enhance to a limited extent the rate of coal gasification. Now, alkali carbonates like K2CO3 are very effective catalysts for coal gasification. Since no simple mechanism is known by which one can explain the catalytic effect of one solid on the rate of reaction of another solid gas. 5 possible rate enhancement modes were considered for the catalytic system char K2CO3, and these mechanisms are: first, the catalysis by the chemical reaction of K2CO3 with oxygen functional group in the char and generation of more active sites. Second, catalysis by generating a dipole due to electric charges on the surface of K2CO3. Third, catalysis by the chemical interaction of K2CO3 with the gases to yield more reactive gaseous species. Fourth, catalysis by interference of K2CO3 with the temperature field associated with the reacting char particle. And the last one, catalysis by interference of the K2CO3 with the rate of adsorption of gases onto the char. Mechanisms first and third attribute the catalytic effect to changes in the chemistry of the reaction, while mechanisms second, fourth and fifth suggest physical effects as an explanation to the catalytic activity of K2CO3. Since K2CO3 enhances the rate of reaction of char with chemically different gases, for example carbon dioxide, hydrogen and water, one may expect the mechanism of the catalysis to be insensitive to the nature of the gas. This observation tends to support catalytic mechanisms which rely more on changes in the physics of the reaction system. However, as will be demonstrated, the most likely catalytic effects relies on a synergetic interaction between the chemistry and the physics of the catalytic system K2CO3 char. Other alkali metal salts of weak acids like sodium carbonate, potassium sulfide and sodium sulfide can catalyze steam gasification of coal. The field of catalysis, that is, the study of catalysts and their use, is large, and this is just one example. Catalysts that have been used for years in petroleum refining have found use in gasification as well, again to lower operating temperatures. Catalysts can also be used to favor or suppresses the formation of certain components in the syngas products. The primary constitution of syngas are hydrogen and carbon monoxide, but other products like methane are formed in small amounts. Catalytic gasification can be used to either promote methane formation or suppress it. Now, the major disadvantages of catalytic gasification include increased materials cost for the catalyst itself, as well as diminishing catalyst performance over the time. Catalysts can be recycled, but their performance tend to diminish with age. The relative difficulty in reclaiming and recycling the catalyst can also be disadvantaged. For example, the K2CO3 catalyst described above can be recovered from spent char with a simple water wash, but some catalysts may not be so accommodating. In addition to age, catalysts can also be diminished by poisoning. Many catalysts are sensitive to particular chemical species which bond with the catalyst or alter in it such a way that it no longer functions. Sulfur, for example, can poison several types of catalysts including nickel, iron, palladium and platinum. Now let us see what are catalysts in coal liquefaction. The economic viability and operability of processes to convert coal to useful liquid products is contingent upon the development and application of effective catalysts. New and improved catalysts can lead to more favorable process economics by increasing the rate of conversion and the selectivity to the desired product, and by allowing operation at reduced temperatures and pressures. The processes of primary coal dissolution and coal liquids upgrading are distinguished. The status and the limitations of catalysts used to promote these reactions are discussed together with approaches which could lead to the development of improved and novel catalysts. The principal factors which contribute to the high cost of coal-derived liquids are the large amount of hydrogen which must be added to remove heteroatoms and to convert materials containing about 5% hydrogen to products with between 12 to 14% hydrogen. The severe reaction conditions such as temperature and pressure and the relatively low rate of conversion which are experienced. In spite of these limitations, there are valid reasons for pursuing research and development in coal liquefaction. Practically every future energy scenarios envisions the development of indigenous fossil fuel resources to supplement and replace materials derived from petroleum crudes. In short term, situation could arise whereby the supplies of imported crudes to oil poor industrialized nations are restricted, and in the long term, world petroleum reserves will eventually be depleted. The catalysts which have been applied to coal liquids upgrading comprises a combination of the metals like cobalt, nickel, molybdenum and tungsten together with promotional additives distributed over a porous support of alumina and silica alumina. The catalyst must be sulfide in order to attain their active form. These catalysts are used extensively in petroleum refining and evolved from catalysts which were originally developed for hydroprocessing distillate coal liquids. No concerted attempts have been made to adapt them by hydroprocessing high boiling coal liquids. Research efforts have focused mainly on catalyst screening and evaluation, and little attention has been given to investigating novel formulations. For most metals, the thermodynamically stable form under liquefaction conditions is sulfide or mixture of sulfides. Fortunately, a number of sulfide metals are active catalysts for coal dissolution. A water or oil-soluble catalyst precursor is normally introduced to the coal or coal solvent slurry in a manner intended to disperse it efficiently. The sulfide catalyst is subsequently produced by the in situ reaction of the precursor with the source of sulfur. For a given metal, the catalyst activity will be a function of its dispersion and the stoichiometry of the sulfide phase. Although many catalysts have been examined in fundamental studies, large-scale investigations have been primarily concerned with two groups of catalyst materials. First, metal sulfides, and second, acid catalysts. The sulfides of metals such as molybdenum and iron are believed to function as hydrogenation catalysts, while metal halides like zinc chloride promotes bond cleavage by an ionic mechanism. In both cases, effective control of the dissolution process requires intimate contact between the catalyst and the coal. In turn, this means that the used catalyst is associated with the reaction products, which complicates its recovery. For this reason, low cost has been a priority in catalyst selection as it allows use on a once-through basis. This has limited the choice of candidate catalyst materials. The development of technologies for catalyst recovery could increase the cost constraint and have a major influence on broadening the source base for the selection of catalysts. So now in this module we have seen the requirement of a catalyst, how the catalyst plays a crucial role in speeding up the reaction rates without being used up or changing its property. Now K2CO3 is an important catalyst required in coal gasification because it catalyzes the chemical reaction of K2CO3 with oxygen functional groups in generation of more active sites. Other alkali metal salts like sodium carbonate, potassium sulfide, and sodium sulfide are also used as an important catalyst in coal gasification. The development of technologies for catalyst recovery could alleviate the cost constraints and also have a major influence on broadening the resource base for the selection of catalysts. Thank you.